a really nice application for the new SKAARHOJ GPIO box is in an OB-van, where you have joystick override from RCP panels like this. So basically, as you press the joystick, you want a GPI on a SKAARHOJ box to change a route on a Videohub. And this device has been programmed in a quite clever way, so the joystick override in a hectic environment will still preserve the original source. And I will demonstrate that in a moment, including how you can set this up in the awesome web interface. So this device has actually two channels of inputs and outputs. There are 8 inputs and outputs on each plug. So you could serve up to 16 RCPs with this box. And you could even split them into 2 groups, so you could have different operators with each a monitor for previewing their sources. Okay, so we'll now connect it underneath the RCP panels so you can see how it works. Joystick override is when you have a CCU joystick and you press it, the source the RCP is controlling is now shown on your preview monitor. As you release it, it jumps back to whatever was there before. And typically an operator would have a panel like this one, which controls a video hub like that, and that decides what the default source on the screen is. So all these joysticks, the GPI outputs from the RCPs are connected to the SKAARHOJ unit on various inputs, and then it is designed so when I press this, it sends a specific route to the video hub, so I see this source on the screen. And as I press this joystick, it's not easy to see, but you can see the camera number changes. I can try this one. This is a gray source. So as I press this one, it comes on, but as I release, it jumps back to this one, and as I release that one, it jumps back to the default source. And if I press this one and hold down this one and then release this one and then release that one, it goes back to that source again. And that is what we call hold groups. If you look at the web interface, you can see how this awesome feature is configured. So this is the SKAARHOJ 16-channel GPIO box, and on input number 1, 2, 3, 4, 5, 6, and 7, we routed it to these RCPs. So for input number 1, you see we are controlling a video hub, route input to output, input number 1 to output number 31, hold group A. And hold group A means that this input, along with number 2, number 3, 4, all these, they are assigned to hold group A. They will collect their, or they will have a common memory of which source was the original one. So the way I would split it up for 2 CCU operators would simply be if, let's say, RCP number 5, 6, and 7 would be a different operator. I would just change it to hold group B, and then he would have his local memory separated from the first operator. And then, of course, you would save it, and the box would perform this action. So we think this is a really cool feature, and we also did quite an amount of work to make it really solid. Like, you can really stress the system and it's gonna bring you back to the default source all the time.